So today we're going to do something a little different. We're not just solving a math problem, we're basically cracking a case. Think of it like a detective story where the culprit is a number and the crime scene, well, it's one monster of an equation.
I mean, seriously, when you're faced with something that looks like this, huge, intimidating, like it could take a week to solve, the first question you've got to ask is, where do you even start? Well, that's the mystery we're diving into. All right, so let's meet our antagonist. This beast right here is a ninth-degree polynomial. It's got 10 terms, some absolutely massive numbers, and one very big question at its core. Our mission is to find that one single value of x that makes this whole thing, poof, equals 0. Yeah, in math speak, we're hunting for the root. Think of it as the secret key, the one number that brings balance to the entire equation and solves the whole puzzle. That's our target.
Now, you can't just charge headfirst into a puzzle this complex. That's not going to work. You need a special tool, a secret weapon. And lucky for us, in mathematics, that weapon is often a very mysterious and very powerful formula. Just imagine our equation is this crazy, unpickable lock. It looks totally impossible to open, right? But what if you had the exact key, the one designed to fit this specific lock? Well, that's what this formula is for us.
And we're not just going to start guessing wildly. No, we've got a plan, a step-by-step approach. We're going to take our puzzle box here, and one by one, we're going to test 10 different keys, the numbers 0 through 9. Now, the goal isn't just to get lucky and find the answer right away. The real goal is to find a clue, a pattern in what comes out. All right, time for the investigation phase. This is where the real detective work starts. We're going to put our formula to the test and see what clues we can dig up. Okay, first key up, the number 0. We plug all the numbers from our huge equation into our special formula, we turn the crank, and what do we get?
0. Huh. Okay. I mean, that's interesting, but one clue doesn't solve a case, right? We're going to need a little more evidence than that. So we press on. The investigation has to be thorough. Next up is key number 1. We do the exact same process, run all the numbers through the formula, and
the result is 0. Again. Okay, now things are getting interesting. Is that just a coincidence? Or are we starting to see the pattern we've been looking for?
We keep going. We try key number 2, 0. Key 3, also 0. 4, 5, 6, all the way up to 9, every single one of them gives us the exact same result. Just a long, monotonous, but kind of beautiful string of zeros.
And this, right here, is the turning point. This is the moment the case breaks wide open. What looked like a bunch of dead ends, a whole lot of nothing, is actually everything. The pattern is staring us right in the face.
I mean, when you lay out all the evidence like this, it's so clear, isn't it? 10 tests, 10 identical results. That's not a coincidence. That is a massive clue. It's telling us that the roots of our polynomial are related in a very specific, and it turns out, very convenient way. You have to totally shift how you're thinking about this. The zeros aren't failures. They're not telling us what the answer isn't. They're actually the solution in disguise, pointing us exactly where we need to go next.
So this is it, the big question. How does a table full of zeros help us solve this thing? How do we turn this pattern into the one number we've been looking for? Well, this is where all that tedious detective work really pays off.
It turns out this consistent pattern of zeros triggers a really neat shortcut in the math. It means that to find the solution, we don't need a crazy complex formula. Almost all the complicated parts of the problem just cancel each other out. The beast that looked so intimidating is about to become incredibly simple. And here is the payoff. The hard way involves this long, messy formula with all the polynomial's different parts and all our test results, but because of the pattern we found, the simple way is just taking a single number from our original equation and dividing it by 9. That's it.
So the calculation becomes super simple. We just take that second number from the equation, 36, make it negative, and divide by 9. After all that complexity, this is all that's left.
And what do you get? You get -4. That's it. That is the root. That's the solution to our massive puzzle. All of that methodical work, all that searching, and it all boils down to this one simple, elegant answer. Case closed.
And that leaves us with one last thought, right? We started out with a problem that looked absolutely impossible. But just by applying a steady, methodical process and by having the patience to look for the simple pattern underneath it all, the complexity just sort of melted away. Makes you wonder, doesn't it? What other intimidating monsters in our own lives are really just simple puzzles waiting to be solved?